Find local maxima and local minima.
Find local maxima and minimum
Of
the function
f of x equal to 3x raised to 4 plus 4x cubed minus 12x squared plus 12. So what is asked in the question? We have to find local maxima and minima of the function. We can use second derivative test. First we will find the first derivative equate to 0. These are the extreme points. Then we will find the second derivatives. In which extreme point it is negative, it is local maxima, and in which extreme point it is positive, it is local minima. That is second derivative test. So let us do f of x is given. So first to find f dash x. What is the derivative? 3x raised to 4. So it is 12x cubed plus 4x cubed. So it is 12x squared minus 12x squared derivative is 24x and derivative of 12 is 0. Let us together find the second derivative as well. What is second derivative? f2 dash of x is equal to 12 into 3, 36x squared plus 12 into 2, 24x minus 24. Now what is the next step? We should equate f dash x to 0 to get the extreme values. So f dash x equal to 0 implies what? 12x cube plus 12x squared minus 24x equal to 0. We can see x and 12 are common factors. Take it outside. So 12x into x squared plus x minus 2 equal to 0. Let us factorize. What is x squared plus x minus 2? Product negative 2 and sum positive 1. So the numbers are plus 2 and minus 1. So it is 12x into x plus 2 into x minus 1 equal to 0. This gives the extreme values. What are the possible values? X can be 0, x can be negative 2 and x can be 1. So the possible values are x equal to 0, negative 2 and 1. Now as they are extreme values, we have to check its second derivative values. What is f2 dash of 0? So what is f2 dash of 0? We have got f2 dash of x. In that substitute x equal to 0. So it is 36 into 0 squared plus 24 into 0 minus 24. What is it? It is negative 24. Second derivative negative means what? Local maximum. So this point is local maximum. 0 is local maximum. Now the second one, f2 dash of negative 2. What is it? 36 into negative 2 squared plus 24 into negative 2 minus 24. What is it? Negative 2 squared is 4. 4 into 36 is 144. 144. Then 24 into negative 2 minus 48 minus 24. So 72. It is positive. As it is greater than 0, what it implies? It is local minimum. This is local minimum. Next is f2 dash of which value? 1. So f2 dash of 1. What is it? 36 into 1 squared plus 24 into 1 minus 24. So what is it? 36 plus 24. 60 minus 24. It is positive. No need of finding exact value. It is enough we got a positive. We can do like that. If we want, we can write the exact value. Otherwise, just write this a positive number. What is the number we are getting? 36, which is greater than 0. Hence, log L minima. So we got at 0, it is local maxima. At 1 and negative 2, it is local minima. Now let us express it as a table. What are things we should write? X equal to 0, x equal to negative 2, x equal to 1. X equal to 0 is what? Local maximum. This is local maximum. X equal to negative 2 is what? Local minimum. X equal to 1 is also local minimum. And we should get that maximum and minimum value. So how to find? We should find what is f of 0. What is f of 0? It is 3 into 0 raised to 4 plus 4 into 0 cube minus 12 into 0 squared plus 12. So value is 12. Maximum value is 12. Now when x equal to negative 2, what is the value? F of negative 2. F of negative 2 is 3 into negative 2 raised to 4 plus 4 into negative 2 cube minus 12 into negative 2 squared plus 12. What is it? Negative 2 raised to 4 means it is 16. So 3 into 16, 48. Then negative 2 cube is negative 8. Negative 8 into 4, negative 32. Negative 2 squared is 4. 4 into negative 12. So it is minus 48 plus 12. Simplify it. 48 minus 48 will get cancelled. Negative 32 plus 12. So it is negative 20. We have to get what is local minimum when x equal to 1. We will get it as f of 1 equal to 3 into 1 raised to 4 plus 4 into 1 cube minus 12 into 1 squared plus 12. So when we simplify, we will get 3 plus 4, 7 minus 12 plus 12 will get cancelled. So what is answer? 7. So this is the conclusion. This is the answer part. So what we got? X equal to 0 is local maximum and that maximum value is 12. X equal to negative 2 is local minimum and that minimum value is negative 20. X equal to 1 is local minimum and that minimum value is 7. Next question. Find two positive numbers whose sum is 15 and sum of whose squares is minimum. So we have to get two numbers whose sum is 15. The two numbers, let us take one number as x, unknown number. So numbers, one is x, other will be what? Sum is 15. So other number is 15 minus x. These numbers should satisfy which condition? Sum of whose squares is minimum. What is squares of this x squared and 15 minus x whole squared? Their sum means x squared plus 15 minus x whole squared. As it is sum, we can use the letter s of x instead of f of x. That's all. So sum of squares. Squares is x squared. Sum 15 minus x whole square. So this is the required equation. Let us simplify this. X squared plus 15 squared to 25 minus 30x plus x squared. So it is 2x squared minus 30x plus 225. We got sum of squares s of x. This should be minimum when the extreme value, when first derivative is 0, and to show it is minimum we should get second derivative is negative. So find first derivative s dash x is 4x minus 30. Find the second derivative s2 dash of x is 4. So we got positive number. This implies what? Sum of squares is minimum. So we got it is minimum. So minimum is got. Now we should satisfy s dash x equal to 0 to find the exact value. So s dash x equal to 0 implies what? 4x minus 30 equal to 0 means 4x equal to 30 or x equal to 30 by 4, so 15 by 2. So we got one number x, other number is what? 15 minus x. 15 minus x is 15 minus 15 by 2. What is it? It is also 15 by 2. So we got the two numbers. What are the two numbers? 15 by 2 and 15 by 2 are the two numbers whose sum is 15 and sum of squares is minimum. Why we are telling it is minimum? Because we got second derivative is positive. So note that when these squares is minimum, the two numbers are equal. So the same question can be asked when sum is 24. The question is sum is 24. What is the two positive numbers? It will be 12, 12. Now the third question. What is the maximum value? What is the maximum value of sin x plus cos x? Maximum value of sin x plus cos x. So function is given. What is the function? Sin x plus cos x. So value should be maximum. So first derivative 0, second derivative negative. Look here. We know maximum value of sin x is 1 and maximum value of cos x is 1. Is it 1 plus 1? 2? No, it is wrong. Because when sin x is 1, cos x will be 0. So it is 1 plus 0. So you will get in that case 1. Is it the maximum? Let us check. F of x is sin x plus cos x. F dash x, find the derivative. Derivative of sin x is cos x and derivative of cos x is minus sin x. What is f2 dash of x? f2 dash of x is negative sin x minus cos x. Okay, so to maximum or minimum, first derivative 0. F dash x equal to 0 implies what? Cos x minus sin x equal to 0. It implies cos x equal to sin x or sin x equal to cos x. When this will be equal? When x is 45 degree or x equal to pi by 4. X equal to 45 degree or pi by 4. We have to show that at this value it is maximum for f2 dash x to be negative. So f2 dash of pi by 4. Instead of pi by 4, if you want you can write 45, no problem. Negative sin of pi by 4 minus cos pi by 4. What is sin pi by 4? Negative 1 by root 2 minus cos pi by 4 is also 1 by root 2. What is it? Negative 2 by root 2. So we are getting negative. Negative means what? F2 dash is f2 dash of pi by 4 is negative. It implies what? Maximum. It is maximum value. Now we have to get what is the maximum value. What is the maximum value? We will get it when we put x equal to pi by 4 in f of x. Let us substitute f of pi by 4. F of pi by 4 is sin pi by 4 plus cos pi by 4. So it is 1 by root 2 plus 1 by root 2. When we add, we will get 2 by root 2. Let us rationalize how into root 2 by root 2. So what is the answer? Numerator 2 root 2, denominator root 2 into root 2, 2. So 2 will get cancelled. So final answer is root 2. So maximum value is root 2. See, when we put a sin x maximum value, it is 1 plus 0, 1. Root 2 is more than that because root 2 value is 1.414. So we got the result sin x plus cos x is maximum when x equal to pi by 4. Or we can tell maximum value obtains when sin x equal to cos. Next question. Find two numbers whose sum is 24 and whose product is as large as possible. So we have to get two numbers whose sum is 24. So what are the numbers? One number we will take as x and sum 24 means the second number we should take as 24 minus x. And what is the function required? Product is as large as possible means product should be maximum. So let us write what is product. For product I am using p of x. If we write f of x, no problem. We can use f of x. F of x. The product. What is the product? X into 24 minus x. It should be maximum when f dash x 0 and f2 dash x is negative. So let us simplify. X into 24, 24x minus x squared. So now what is required? The product should be as large as possible. Product large means product should be maximum. So the condition is first derivative 0, second derivative negative. Let us find first derivative f dash x. 24x derivative is 24 minus derivative of x squared is 2x. What is second derivative? f2 dash of x. Derivative of 24 0. Minus 2x derivative is negative 2. So we got second derivative negative. It implies what? Product is maximum. Negative implies product is maximum. Now what is that maximum extreme condition? For that f dash x should be 0. So f dash x equal to 0 implies what? 24 minus 2x equal to 0. 24 minus 2x equal to 0 implies 2x equal to 24 or what is x? X equal to 24 by 2, 12. So when x is 12, the other number is 24 minus x. What is 24 minus x? It is also 12. 24 minus 12, 12. So what are the numbers? We got the numbers as 12, 12. So these are the two numbers whose sum is 24 and product is as large as possible. Next question. Show that of all rectangles with given perimeter, the square has maximum area. The square has maximum area. So what is the question? Rectangle with a given perimeter means perimeter rectangle is given. It is a fixed number and area is maximum when that rectangle is a square. Rectangle is a square means length should be equal to breadth. How to do? Perimeter is given. What is perimeter of rectangle? 2 into L plus B. Let us take L as x. Okay, so what is perimeter? B we should find based on the perimeter. What is perimeter? Perimeter is 2 into L plus B. So what is B? What is B? L plus B is P by 2 or B is P by 2 minus L. But we have taken L equal to X. So it is P by 2 minus X. So we got L and B. What is L? L is X. And what is breadth? P by 2 minus X. Square has maximum area, means the required function is area function. What is area? Area is area of rectangle, LB. Area is LB. So X into P by 2 minus X. P should be treated as a constant. Why? Because given perimeter means it is a constant. Multiply by X, what we will get? P by 2X minus X square. So what is A dash X? A dash X is P by 2 minus 2X. What is A dash of X? P by 2 is a constant and negative 2X, so it is negative 2. So we got negative. Negative means what? Maximum area. Maximum area when A dash X is 0. When A dash X is 0. What is A dash X? P by 2 minus 2X is 0. It implies what? 2X equal to P by 2 or X equal to P by 4. X is what? Length. So we got length equal to P by 4. Let us find breadth. What is breadth? Breadth is P by 2 minus X. So B is equal to P by 2 minus X. X is what? P by 4. So P by 2 minus P by 4 is equal to P by 4. So we got breadth is also P by 4. See here, length and breadth are equal. Length equal to breadth implies what? Rectangle is a square. So rectangle is a square. That is asked to prove. Maximum area is square. Next question. Prove that radius of the right circular cylinder. The right circular cylinder. The radius of right circular cylinder of greatest curved surface area. Of greatest curved surface area. Curved surface area means CSA, which can be inscribed. Which can be inscribed. Which can be inscribed in a given cone. In a given cone is half of that of the cone. Is half of that of the cone. So what is to be found? Prove that. We have to prove that radius of right circular cylinder of greatest CSA. So cylinder has maximum CSA, curved surface area, which can be inscribed in a given cone. So cylinder is inscribed in a cone, and we have to show that cylinder radius is half of that of the cone. Cylinder radius is half of the radius of the cone. That is asked to prove. So let us draw a figure. What is it? A cylinder is inscribed in a cone. So a cone. Cylinder is inscribed in this. This is the cylinder inscribed in it. It is asked to show this cylinder has half the radius of the cone. So this is the radius. This is the radius of the cone and this is the radius of the cylinder. So let us use big letter and small letter R. Cylinder, the biggest one, the cone radius big letter R, and the small radius, cylinder radius, let it be small letter R. Similarly, the height of the cone is there and the height of the cylinder is also there. So for height of the cone, let us use big letter H, and for height of the cylinder, let us use small letter H. Is there any relation between this R and H? Look at the picture. A, B, C, D, E. Look here, you can see triangle ABC and triangle DEC. They are similar triangles. When triangles are similar, their corresponding sides are proportional. So look at the triangle ABC. What are the sides? This side is R and this side is H. So for proportionality, R by H. For the bigger one, what is the smaller triangle? DEC. DEC. In corresponding to big letter H, there is small letter H. And corresponding to big letter R, it is not a small letter R because small letter R is BE. The required triangle needs a side EC. What is EC? The big letter R minus small letter R. So we can, instead of R, will come big letter R minus small letter R by H. Small letter H. Because we need the triangle side EC. EC is big letter R minus small letter R. The cone is given means big letter R, big letter H is given. The variables are only small letter R and small letter H. So we have to eliminate one variable. With the two variables we cannot do problem because A of X or F of X is doing. Let us take R equal to X. Let us take the small letter R is equal to X. Based on that, find big letter H. Based on that, find small letter H. What is small letter H? Small letter H is equal to R H cross multiply R H is equal to H into R minus R. So what is small letter H? Big letter H by big letter R into R minus R. We are taking small letter R as X. So what is small letter H? Small letter H is equal to big letter H by big letter R into big letter R minus X. So we are taking small letter R as X and small letter H as H by R into R minus X. The greatest CSA, cylinder has greatest CSA, so area function. What is curved surface area of cylinder? 2 pi RH. A of X is 2 pi RH. What is RH? R is what? Area formula we want, we can write 2 pi RH. R we can substitute X. H is what? This one. H by R into R minus X. Let us simplify this. A of X. Constants grouping. 2 constant pi group. Constant H by R is also a constant. Let us take this X2 inside. So it is big letter Rx minus X squared. For maximum or minimum, first derivative should be 0. What is first derivative? What is A dash X? A dash X 2 pi H by R is a constant. And what is derivative of Rx? It is R minus what is derivative of X squared? 2x. Let us find the second derivative. A2 dash X. A2 dash X is 2 pi H by R and derivative of R is 0 and derivative of negative 2x is negative 2. So altogether we are getting negative. Negative implies what? Maximum CSA. So maximum CSA we got when a dash x is 0. Let us equate a dash x equal to 0. A dash x equal to 0 implies what? It implies 2 pi h by r into r minus 2x equal to 0. These are all constant, they can never be 0. So only possibility is r minus 2x equal to 0 or 2x equal to big letter r or small letter x equal to r by 2. What is small letter x? The radius of the cylinder. So instead of x we can write small letter r is equal to big letter r by 2. This is asked to prove. The next question. An open topped box. An open topped box. A box like this. An open topped box. An open topped box is to be constructed by removing equal squares from each corner of a 3 meter by 8 meter rectangular sheet of aluminium and folding up the sides. Find the volume of largest such box. So a sheet is given. From the sheet, from each corner, it's aluminium sheet, 3 meter by 8 meter. From each corner, one square is cut and it is folded up. When it is folded up, when the sides are folded up, it will form a rectangle. So let us understand this question by the figure. An aluminium sheet is given with the side 8 meter by 3 meter. So length 8 meter and breadth 3 meter. This is to be converted into a box open at the top. How this can be made to a top? Opened box. From each corner, square is cut off. And the remaining portion, it is folded up to make it a box. We don't know what is the length square cut off. Let us take it as x. Now look at this remaining portion. The squares are cut off. These are gone. This is the portion. And from here it is folded up to make the box. So this will be the base of the box. Isn't it? This is base of the box. With this length and this breadth. And x will be the height of the box. So what is length of the box? This is length. What is length? Total 80 meter. From that x and x cut off. So length is 8 minus 2x. Now what is breadth? From 3x and x cut off. So breadth is 3 minus 2x. And what is height of the box? X. Now which function is required? Volume of largest such box. So volume function is required. What is V of x? It is a rectangular box. Volume is LBH. What is L? We got here 8 minus 2x. And what is breadth? 3 minus 2x. And what is h? The height folded up is x. So this is volume. Let us simplify. 8 into 3, 24, minus 8 into 2x, 16x, minus 2x into 3, 6x, plus 2x into 2x, 4x squared into x. So x squared into x cubed. So first term let us write a 4x cubed, minus 16x, minus 6x. So it is minus 22x into x, minus 22x squared. Plus 24x. So we got volume function. Maximum volume, largest such box means maximum volume. So v dash x should be 0 and v2 dash x should be negative. What is v dash x? It is 12x squared minus 44x plus 24. What is v2 dash x? Is 24x minus 44. So v dash x equal to 0. V dash x equal to 0 will get what? We will get as 12x squared minus 44x plus 24 equal to 0. Simplify this. 4 is a common factor, cancelling. 3x squared minus 11x plus 6 equal to 0. All this. Let us use formula method. X equal to negative b plus or minus root of b square minus 4 is equal to a. So x equal to 11 plus or minus root of 11 squared minus 4 into 3 into 6 divided by 2a, 2 into 3. Simplify. 11 plus or minus 11 squared is 121 minus 4 into 3 into 6. So what is it? 4 into 3, 12. 12 into minus 72 by 2 into 3, 6. Simplify. 121 minus 72. It is 49. And root 49 is 7. So it is 11 plus or minus 7 divided by 6. 11 plus 7 is 18. 18 by 6. Or 11 minus 7. What is it? 11 minus 7 means 4. So it is 4 by 6. So what are the values obtained? 18 by 6 is 3. So x equal to 3 or 4 by 6 is 2 by 3. So we got the two values. X equal to 3 or 2 by 3. Are the two values possible? X equal to 3 possible? No. Why? Breadth of the rectangular sheet is only 3 meter. From that, how can we cut 3 meter from both sides? It is not possible. So only possible value is 2 by 3. So x cannot be 3. So x is equal to 2 by 3. We got the side to be cut is 2 by 3. With this value, we should show V2 dash is maxima. Means it should be negative. What is V2 dash of 2 by 3? It is 24 into 2 by 3 minus 44. So simplify. This is 8 into 2, 16 minus 44. Negative 28. Or it is negative. Negative implies what? Maximum volume. So we got maximum volume when x equal to 2 by 3. So what we got? Maximum volume or largest volume when x equal to 2 by 3. Now it is asked to find that maximum volume. What is volume? Volume is LPH. Or we got volume. V of x is 4x cube minus 22x squared plus 24x. In that put x equal to 2 by 3. So volume is 4 into 2 by 3 cube minus 22 into 2 by 3 squared plus 24 into 2 by 3. Simplify. 3 cube is 27, 2 cube is 8. So 8 into 4, 32 by 27. Minus 3 squared is 9, 2 squared is 4. So 4 into 22, 88 by 9. Plus 24 into 2, 48 by 3. Take LCM 27. When LCM is 27 taken, 32 minus 88 into 3. Because 27 is 9 into 3. So 88 into 3. 88 into 3, 264 plus 48 into 9 because 27 3 into 9. So 48 into 9. 48 into 9 432. Simplify it. 32 plus 432 is 464. 464 minus 264. So it is 200 by 27. So this is the maximum volume. And as it is a meter, you can write it as meter cube or cubic meter is the maximum volume 200 by 27. Next question. A circular disc of radius 3 centimeter. So a circular disc of radius 3 centimeter is being heated. Due to expansion, its radius increases at the rate of 0.05 centimeter per second. Find the rate at which its area is increasing when radius is 3.2 centimeter. Let us understand the question. A circular disc of radius 3 centimeter, a circular disc, it is heated. When it is heated, it will expand. Due to expansion, radius increased at the rate of 0.05 centimeter per second. So radius increase rate is given. So it is given dr by centimeter per second. Dr by dt is given as 0.05 centimeter per second. Find the rate at which its area is increasing. So area rate is asked. dA by dt is asked. dA by dt is asked. When the radius is 3.2. So it's a simple question. dA by dt is asked when r is 3.2. What is the shape? It is circle. So what is area? Area is pi r square. What is dA by dt? Pi constant, derivative of r squared is 2r dr by dt. Substitute the value of dr by dt and r. So pi into 2 into r is 3.2 into dr by dt is 0.05. When we multiply 2 into 0.5 is 0.1. 0.1 into 3.2. So it is 0.32 pi. 0.32 pi, and what should be the unit? It is dA by dt, area. So it is centimeter squared or square centimeter per second. So answer is 0.32 pi centimeter squared per second. Next question. Find absolute maxima and minima. Find absolute maxima and minima of the function f of x equal to 2x cube minus 15x squared plus 36x plus 1 in the interval, closed interval 1, 5. So what is asked? Absolute maxima and minima. Here the term is absolute. It is not local maxima or minima. What is difference between absolute and local? Let us understand what is absolute maxima. The interval is 1, 5. If the function is like this, whatever be a rough hand picture, we know this is a local maxima, this is local minima, and this is local maxima. In this whole interval we have to check, including the 1 and 5 endpoints. So within the interval 1, 5, we will see where is maxima or minima occurring, and in 1, 5 also we should check as it is the closed interval. So how to do this? First we will find f dash x. What is f dash x? F dash x is 6x squared minus 30x plus 36. For maxima or minima, we know f dash x is 0. So f dash x is 0 implies what? 6x squared minus 30x plus 36 equal to 0. 6 is a common factor. Cancel it. So it will become x squared minus 5x plus 6 equal to 0. Factorize. Sum is negative 5, product plus 6. What are the numbers? X minus 2 into x minus 3 equal to 0. Look here, minus 2, minus 3, minus 5 and minus 2 into minus 3 plus 6. This implies what? X equal to 2 or 3. So these are the possible values of x at which minimum or maximum may occur. Now how to check it is maximum or minimum? We will find even at the end points we have to check. So f of 1 we will find, then we will find f of 2, then we will find f of 3, then 2 or 3 and then the end point f of 5. All these values we will find, and which is the maximum among them is the absolute maximum and which is the lowest among them is the absolute minimum. So what is f of 1? In f of x substitute 2 into 1 cube minus 15 into 1 squared plus 36 into 1 plus 1. Simplify. 2 minus 15 minus 13 plus 1 minus 12 then plus 36, so it is 24. Now find f of 2. F of 2 is 2 into 2 cube minus 15 into 2 squared plus 36 into 2 plus 1. 2 cube is 8. 8 into 2, 16. 2 squared is 4. 4 into 15, 16. 36 into 2, 72 plus 1. So altogether it will be 29. F of 3 is 2 into 3 cube minus 15 into 3 squared plus 36 into 3 plus 1. Simplify it. 3 cube 27, 2 into 27 54. 3 squared is 9, 15 into 9 135. 36 into 3 108. It is 28. Now f of 5, 2 into 5 cube minus 15 into 5 squared plus 36 into 5 plus 1. Simplify it. 5 cube is 125. 125 into 2, 250. 5 squared is 25. 25 into 15, 375. 36 into 5, 180 plus 1. When we simplify, we 56. Now look at the 4 values. Which is the maximum? 56 is maximum. And which is minimum? 24 is minimum. So how to write the answer? Find absolute maximum and minimum is asked. So absolute maximum when x equal to 5 and maximum value is what? 56. This is one answer. And absolute minimum when x is 1 and minimum value is 24. This is the answer. So when we find absolute maxima and minima, even at the end points of the interval, we have to check. That is the difference between local maxima and absolute maxima. This finishes the question.